thinking about incident, can you take like your record one and then have like a little pie party or something?
If I can make it, if I make it, if I make it, sure. If I make it to like 20,
You're having a little party on the 25th.
I don't see it coming. Did I share my screen? I think, yeah, I'm good to go. I'm recording. All right, so all I want to do today is add tangents. So remember, there are 16 angles on the unit circle. There's 3, 3, 3, 3, and then 13, 14, 15, 16. Tangent, T-A-N-G-E-N-T. So far we have talked about the sine function, which I hope I was able to get you some buy-in as to why the sine is the vertical coordinate. The cosine we've also talked about, and we now know that we recognize that on the unit circle as the horizontal coordinate. The tangent is interesting, and part of me wants to just tell you what it is, but I want you to see again why we're going to get away with what we're going to get away with. So you guys all took a class called geometry, and in that class you learned the tangent ratio. Now I will say it's probably been a while, but we busted these out the other day. Remember SOHCAHTOA? Right. So we have learned that we're working with triangles. We've accepted that we're working with triangles that have 1 as the hypotenuse, right? So let's take this as like a 30, 60, 90. Not that it really matters, but in this case, let's just call it that. What do you know tangent to be at this point? It's opposite over adjacent, right? Right? SOHCAHTOA, not SOHCAHTOW. But honestly, the cotangent will be adjacent over opposite. So that's pretty dope foreshadowing you just did there. But anyways, the tangent you currently know like this. You know that the tangent of an angle is equal to the opposite side divided by the adjacent side. So let's talk about that for a second. So say we're in a triangle like this. And we know that the length of this side is 1/2, right? And we know that the length of this side is √3/2. Everybody okay so far? What is the tangent? Could you figure it out for me? It's opposite over adjacent, right? Which means we have to do a bunch of math, correct? And so the tangents are ones that will be harder for us to memorize just because we don't see them the same way. Once you get your brain fully 100% like liquid smooth with the sines and the cosines, then you can start to make room for the tangents. But job one is to memorize all the sines and cosines. But now we have to bring in tangent, who is opposite over adjacent. Okay. And again, we already know that the sine and the cosine are these. We already had this lecture about the importance of this side being 1. That makes everything so easy when it's a 1, right? Adjacent over 1 is adjacent, opposite over 1 is opposite, like we don't need the 1. So if we're going to calculate, say for our first one, let's say we wanted to calculate the tangent at pi/6. That's the way this is going to start to look. The tangent at or of pi/6. This is a math problem. It's not going to come to us in some blaze of understanding from a triangle. It's a ratio. It's a division problem. So make sure you divide them in the right order. Remember, tangent is the opposite divided by the adjacent. So we're going to do the opposite side, 1/2, divided by the adjacent side, √3/2. Okay. And the good news is, you might say, God, do we have to do this for all the angles? And the answer is, well, not really, because if, just like before, if we find the tangents in quadrant 1, we know the tangents in quadrants 2, 3, and 4 are going to be the same. We just have to mook around with the signs. So help me out with this math stuff. It vexes me. How do you divide a fraction by a fraction? Yeah, copy dot flop. So I'm going to take the 1/2 and I'm going to leave it alone. I'm going to change it to a multiplication problem, and I'm going to flip the second fraction over into 2/√3. What's going to happen? It's going to turn into 1/√3 because, of course, those 2's are going to cancel. And what does that become? Why is that answer not okay? Because you can't have a root on the bottom, right? And how do we fix it when there's a root? Like, we don't just accept, right? We multiply the top and the bottom by the root we're trying to make go poof. So I'm going to multiply the top by √3, and I'm going to multiply the bottom by √3. Eventually, you don't show this step You hang out and do enough work like this, you just start to see them become what they're supposed to be. Like it happens pretty soon from here. So what do we get? Beautiful. So we just encountered a new one, just as familiar as I think right now you are with like √3/2 and √2/2.5. You're going to become just as familiar now with this. Okay. So we can now say that the tangent value at the angle pi/6 is √3/3, and we can add that onto our unit circle, which is pretty rad. So I'm going to go back to my unit circle. And I know there's not a blank for it, so you're just going to have to probably write it off to the side. But what I could do is just like right up here by the points is I could just write like tangent is √3/3. So there you go. Meet the new guy. There he is. And he's going to pop up a lot of times. Well, 4 times to be specific. The middle one is nice. Like if you're just kind of feeling you're not all stressed and stuff, you'll see this with clarity. Just, it's 1. Good. And you see that already, because if you think about it, and I'll show you what I mean, but like if you think about the tangent of 45 degrees or pi/4, it's sine divided by cosine, right? I don't know if I ever actually said that out loud. Have I officially said that out loud yet? God, what an idiot. Listen, we need to say this. The tangent at any angle, I should not have that capitalized, by the way. It's not supposed to be capitalized. The tangent, because that stands for something else. The tangent at any angle is equal to the sine divided by the cosine. I cannot believe I just brushed past that like an idiot. You need to write that down. That's my bad. I'm not counting it as an incident though, because I caught it. That's huge. So as we go around, I don't know why I just assumed that you would deduce that from the garbage I was spouting on about. As we go around the circle and we want to calculate tangent values, we use already what we know about sine and cosine values, and we just divide them. So that should help you to see why it's so hilariously obvious that the tangent at pi/4 or the tangent at 45 degrees is 1, because you're taking √2/2 and dividing it by √2/2. And what's anything divided by itself? 1. So if you wanted to, does anyone need to go over that again? Tangent is 1, right? At those perfect, those northwest and southeast corners, those are 1s, -1s maybe. Let's head around our unit circle and get those all plugged in. Because while we're thinking of it, we might as well take, those are like freebies. So up here in quadrant number 1, we would agree that the tangent value right here at like perfect northeast tangent is 1. Right? Okay. Emma, you good? Okay. Let's head over to the northwest corner up here, like pointed towards, I don't know, Idaho or something. What is the tangent up here? It's going to be -1. Good. So the ratio is still the same, except now we're dividing positive √2/2 by negative √2/2. It's still something divided by itself, but it comes out to be -1. And I know I'm going out of order, but let's just knock these out while we're here, right? Let's head down to the southwest corner. So now we're pointing down towards like Las Vegas down here. What is the tangent down here in quadrant 3? 1. Yeah. And then finally, let's head down and point towards like Texas. What is the tangent down here in the southwest, southeast? -1. Those are nice. What come test day when you see like, tangent of pi/4, you're like jackpot. Thank you. Like easy peasy. We love those the best. Okay. Kind of a couple more topics and then we can finish this off. I think we'll probably get this done today. So let's head up now to this angle, the one I just circled in red. Again, without looking, what's his name? pi/3. Good. So let's head over to the other paper where I'm just doing my scratch work, and let's together for the first time, and probably the last time, manually calculate the tangent of one of the tall angles. because those tall triangles exist in 4 different places. Right, so we only need to do this once. Don't reinvent the wheel here. So to find the tangent at pi over 3, I need to do the sine at pi over 3 divided by the cosine at pi over 3, right? Show a little bit more work this time. What's the sine way up there at pi over 3? Yeah. What's the cosine up there at pi over 3? Right. This one's nicer. You'll come to appreciate the tall tangents, as we call them, like the taller up here and the lower down here. They're the ones that are less annoying. So if we simplify this out, we have root 3 over 2 times 2 over 1. The 2's cancel. What do we get? That's it. So we just call that root 3. So we can now say this is a fact, that the tangent at pi over 3 equals just root 3. Gorgeous. You start to see the future and how easy it's going to be to get root 3 confused with root 3 over 3. So you'll just have to remember, like I did when I learned this, that again, the ones up north, the closer to the north and south poles, those, I can't call it what I was about to call it something terrible. Choose different words. Those ones up there and down there are your, so it would have been, so that would have been an incident. They're root 3s. Got it? And then your ones that are out closer to the east and west sides, those are your root 3 over 3s. Easy peasy. So let's go back to the circle, get it filled in. I'm going to laugh about that. I'm going to tell my wife at dinner about that. That was a close call. The tangent is root 3 up there. Now, as you see, Cooper's gone. I saw Blair fading a minute ago. Do you guys need like 1 minute to take a break? Do you need a quick? Sure. Let me pause this and. Okay, I'll pause the recording. Fill in some more tangents. Are you okay on this, Bryn? All this stuff is good? Okay. So what I was attempting to tell you is I want you to kind of see the symmetry of the circle, and I'm gonna so what I have over here on the board is I have a red and a purple. Those reds are going to be repetitive, and they're the ones, I said this earlier, that are up closer to the North Pole and closer down to they're like the vertical stretched ones, and they're all going to be the same tangents, just positive or negative, right?
Also, if you fold it, it makes sense.
Does it? To
Yeah,
you, like fold
if
the
you
circle?
take the box,
Right.
then it's-
Yep. And you see the same triangles exist all around the unit circle. So like if I went to this angle over here, what's his name? That angle that I just circled in red. It's 2 pi over 3. Very good. So if I went over to 2 pi over 3, I know exactly already what his tangent's going to be. I just have to be smart about the sign. What's it going to be? Right. Its tangent there is negative root 3. And people that say that you shouldn't make kids memorize things, they're not right. That's not true. You have to make room for some common basic knowledge. And one of those things is memorize where your tall tangents are and memorize what your long sideways tangents are. So we can find that same number 2 other times on the unit circle. So if we head down to this angle, what's his name? 4 pi over 3. What's his tangent?
Root 3.
It's root 3. And it's that same ratio, but we arrive at a positive because the sine and the cosine are both negative down there. And when you divide a negative sine by a negative cosine, you get presto, a positive tangent. Does that make sense? Okay. And then the last of the vertical stretchy tangent points, angles is down here. What's his name? Not the angle.
5
Bless you. 5 pi over 3. Yeah, bless you. So at 5 pi over 3, what's the tangent going to be? Negative root 3. It's the same ratio again. It's just negative now because sine is negative being divided by a positive cosine. Negative divided by positive, all that basic stuff. Okay. And then to finish this off, let's get this done and then we will officially call it a day. Yes, I will make myself call it a day. Unless you're really excited and you want to do tangents, we could do tangents at the quadrantals.
I think my frontal lobe.
I don't
I
believe.
feel like Billy Bird or he's like, I don't know.
I mean, if we get the quadrantals done, then we can make it official and say we're done. Like we're ready to move on and keep doing stuff. So that'd be rad. Anyways, let's go to the purples. So we already know purple right here, that pi over 6. So he's a stretcher sideways. And what's his tangent? Right. So we're gonna same exercise here. We're gonna keep seeing that same answer, only it's gonna go from positive to negative to positive to negative, because we're dividing negatives and positives, right? So the next angle that's a sideways stretchy is over here. What's his tangent? Negative √3/3. Is everyone understanding why these go from negative to positive?
Yeah, because some of them have negatives and then they divide.
Right, yes. It's all about,
Positive, one negative, negative, two negatives.
yes, just like that. So the other sideways stretchy is down here. What's his name? With the angle? 7 pi over 6. And I agree with you, Emma. It is definitely positive √3/3. And it's the same thing again. It's positive because we're dividing a negative sign by a negative cosine. So we're back to that again. And then our last horizontal stretchy is over the way last one. He's like the last unit circle angle. What's his name? He's 11 pi over 6, right? I'm going to keep hitting you with those angles. So I want us to get to a point where we're quick. Don't forget all this stuff over the weekend. Yeah.
I forgot it overnight.
I know. How bad's it going to be on Tuesday? I don't even know what you're talking. What's a pi? Like, so don't do that. Try to. I don't even know. What's this pi stuff? What's the tangent down here at 11 pi over 6?
I don't know, you could have negative pi.
Yeah, let's call that good. So we'll just pick up the quadrantal tangents on Tuesday, and then that's that.
I'll tell you, Aaron, I don't know. I don't know what happened last time, but I didn't. Brady, were you tracking this one?